Now let us verify whether this function is even or odd. So here I am going to redefine this function. Why? Because we have to make it free from modulus sign as well as integral part sign. So that is what I have to redefine this function. Here x into mod x. For x less than or equal to minus 1, mod x is nothing but minus x. Why? Because mod x is equal to plus x when x is positive, minus x when x is negative, 0 when x is equal to 0. Right? Here x is less than or equal to minus 1. The values of x which are less than minus 1 are all negative. Hence mod x becomes minus x. So x into minus x, it is minus x square. Similarly, next one. Do you remember this property? Integral part of x plus n is equal to integral part of x plus n, if n is any integer. Even here, let us consider the second function, integral part of 1 plus x plus integral part of 1 minus x. Here 1 is an integer. Obviously, we can write it as 1 plus integral part of x plus 1 plus integral part of minus x. Here 1 plus 1, it becomes 2 plus integral part of x plus integral part of minus x. Now the second function can be written as 2 plus integral part of x plus integral part of minus x. For minus 1 less than x less than 1. Similarly, third function. Here x is greater than or equal to 1. So all the values which are greater than 1 are all positive. The values of x which are to the right of 1 are positive. Hence mod x becomes plus x. So minus x into x. Now it happens to be minus x square. Now I am going to rewrite it. Now f of x can be written as, this is minus x square whenever x is less than or equal to minus 1. Now do you remember this property? Integral part of x plus integral part of minus x is equal to 0 if x is an integer, minus 1 if x is a non-integer. If x is a non-integer. So between minus 1 and 1 there is an integer 0. So break this interval at 0. Now I am going to write it as minus 1 less than x less than 0 as well as x is equal to 0 and 0 less than x less than 1. So the values of x in between minus 1 and 0 are non-integers. Then integral part of x plus integral part of minus x becomes minus 1. Now the second functional value is 2 plus of minus 1. 2 plus of minus 1, 1. Now for x is equal to 0, obviously 0 is an integer. Integral part of x plus integral part of minus x is 0. 2 plus 0, this is 2. Similarly, in the fourth case, 0 less than x less than 1. Even here, every real number between 0 and 1 are non-integers. So 2 plus integral part of x plus integral part of minus x is nothing but minus 1. 2 minus 1, 1. And what about the next one? For x is greater than or equal to 1, it is defined as minus x square. Now let us draw the graph of f of x. In fact, the graph of x square looks like this. It is an upward parabola with vertex at origin. This is the graph of x square. Similarly, the graph of minus x square. It is a downward parabola. It looks like this with vertex at origin. So here I am going to draw the graph of f of x for that region. Take x-axis, y-axis. For x less than or equal to minus 1, it is defined as minus x square. When x is equal to minus 1, its value is how much? Minus of minus 1 whole square. Minus 1 whole square is nothing but 1. So obviously it is minus 1. Similarly, for x is equal to minus 2. Minus of minus 2 whole square. Obviously it is minus 4. For x is equal to minus 2, it is minus 4. Here it is a downward parabola, a branch of a downward parabola, it looks like this. So this is a graph of minus x square, whenever x is less than or equal to minus 1. Similarly, between minus 1 and 0, it is defined as 1. Between minus 1 and 0, it is defined as 1. Similarly, for x is equal to 0, it is defined as 0. Again, between 0 and 1, it is defined as 1. At x is equal to 0, it is defined as 2. Sorry, it is not 0. It is defined as 2. And between 0 and 1, it is defined as 1. For x greater than or equal to 1, it is minus x square. For x is equal to 1, it is minus 1. For x is equal to 2, minus 2 square. Again, it is minus 4. So this is the part of parabola y is equal to minus x square. It looks like this. So obviously, this graph is symmetric about y-axis. Since it is symmetric about y-axis, we can say that it is even function. Since y is equal to f of x is symmetric about y-axis, then it is an even function. That's it. Therefore, f of x is an even function. So each and every even function is symmetric about y-axis.